All right, this is Precalculus, Chapter 13, Lesson 1, homework up on page 851. Number 1. Okay, we're going to just identifying the population and the sample. All right, so number 1. There are 3 schedule options for classes at high school. 90-minute classes every other day, 90-minute classes every day for a semester, 45-minute classes every day for a year. Out of 1,200 students, 50 will be chosen at random and ask their preference. So what is the population? What? The 1,200 students, and the sample is?
50.
The 50 students. That's all it was asking.
Would I be able to test?
Very possibly. Okay. That's it.
I like this lesson.
Don't tell it be like this.
I like them when it's just numbers.
Okay.
I like them.
Now we have to go back on one. Now we're number 5. It says determine whether the data in 1 through 4 is qualitative or quantitative. If it's quantitative, discrete, or continuous. Okay. So number 1, is the data qualitative or quantitative? It's qualitative because it's your preferences. Do you prefer a 90-minute class every other day, a 90-minute class every day, or 45-minute classes every day for a year? All right, so it's a quality, it's categories, different categories, right? Number 2, the manager of a convenience store wishes to determine how many cartons of eggs.
Wait.
This is still number 5.
Oh.
We're answering the data in number 2. Is it qualitative or quantitative? Okay, got it? So we're going to determine how many cartons of eggs are damaged in a shipment. For 10 shipments of 1,000 cartons, she examines every 50th carton to see how many contain cracked eggs. What is it? Are we looking, what are we looking at? What are they examining? How many eggs there are? Or whether or not they're cracked or good. It's a category. Got it? So it's qualitative. Yes. Either cracked eggs or not. That's what they're looking at. All right, number 3, a survey is taken on number of pets. A computer is used randomly to select 5 states, then 10 counties in each state, then 50 families in each county. Each of these families is asked how many pets they own. Qualitative or quantitative? It's quantitative. What would have made it qualitative? What type of pet? That is correct. All right. Is it continuous or discrete? Has a minimum number. So that's discrete. Like you don't have a decimal of a pet.
I mean, what?
A fraction of a pet. Well, you might. I know. My poor Benji. My poor Benji. He feels sort of less than 1, but bless his heart. Okay. A biologist tranquilizes 400 elephants, measures the lengths of their tusks to determine their ages. So, qualitative, quantitative. Measures the lengths of their tusk. That is quantitative. Okay, this is where I'm fuzzy at. Discrete or continuous?
Both.
It's really continuous.
It has to be continuous.
It's really continuous because there's not like it's minimum inch. However, okay, I'm not going to argue about that anymore.
It doesn't
Not arguing about it.
It's both. It's both.
Okay. This is really easy. Number 11. You're going to complete the table above.
So it is 50.
20 out of 50 is the relative frequency for aerobics. Remember, you can write it as a percent, a decimal, or a fraction.
This is so easy.
It is so easy.
It's gonna get harder the rest of the chapter, probably.
It will. Okay, I think probability is harder. I think statistics is easier. Yes. Maybe hard because I struggle teaching it, maybe. I'm going to give you two basics, right? Where I'm going to teach you the material, but then I'm going to say, okay, this is really all you need to think about. I think it's just so complicated. Yes, yes. All right, y'all got number 11?
This is a grueling exercise.
It's grueling. Create a bar graph.
I guess mine's too good for this.
Okay, this is not rocket science, okay? Here's aerobics, kickboxing, what is that? Tai Chi? I don't know. Stationary bike. I'm going to go by fives. 5, 10, 15, 20. All right, aerobics is 20. Remember, in a box graph, the bars don't touch in a bar graph. I don't know why I keep calling it a box, because I got that box and whiskers thing stuck in my brain. Kickboxing is 8. Is that Tai Chi?
Yep.
Okay. Is also 8. And then a stationary bike is 14. All right, that's all it was asking for 13. Oh my goodness, y'all. We are going to be done early.
I hope so. Might.
Okay. Let's look at 15. Everybody has this, right?
Yes.
All right. We're going to complete a frequency table for the information given. All right, so we have favorite color. We have red, we have blue, purple, green, yellow, orange, all right? Now here's the frequency. The frequency literally is how many choices there were. So 6 chose red, 8 chose blue, 5 purple, 4 green, 1 yellow, 1 orange. How many is that in total? 25. Okay. So the relative frequency, I don't care how y'all write it, I'm writing it as a fraction. It's 6 25ths, 8 25ths, 5 25ths, 4 25ths, 1 25th, 1 25th. Remember, you can write those as decimals, fractions, or percentages, but their sum total must be 1 or 100%. Now, 17. Okay, now we need to convert these to percentages because it wants us to do a bar graph. So y'all give these to me in percentages. What's 6 divided by 25 as a decimal? 0.24. So it's 24%. What is this one?
3, 2.
And this one?
Oh, 2.
2-0.
Yeah, sorry.
And 4 over 25?
25.
0.6.
And 1 over 25?
0.04.
Okay, so that's 24%, 32%, 20%. This is number 15, but we convert them to decimals so that we could do, what's that number? 17. Do a bar graph. Okay, so I'm going all the way up to 32. I'm going to count by fives again. 5, 10, 15, 20, 25. This is a strange question. It wants the relative frequencies. Here's your relative frequencies. So for red, up to 24%. This is percent, right? I'm making skinny bars. And then this one is 32.
Wait, why are we using the?
Look at the question, number 17. Create a bar graph with the vertical axis showing the relative frequencies. It wanted the relative frequencies.
But isn't it?
Not the frequencies, the relative frequencies. So it's percent of the whole. Okay, so now this one's gonna be 32. I'm gonna go above my numbers. I didn't go up high enough. All right, P is 20. G is 16. Yellow is 4. And orange is 4. Okay, something like that. All right. That was 17. 21. Okay, I gotta read those. State whether the shape of the distribution is best described as uniform, symmetric, skewed right, or skewed left. What is it? Skewed. Skewed left is number 21. Oh my goodness, y'all. That was so easy. All right, 23. The position of the second hand of a clock at 100 random times during a 12-hour period. What do you think?
Probably has to be like
It's gonna be like the same. Because
It's the same, uniform.
There's no basic number.
Uniform. Okay. Now 25. Create a stem plot. Before I do that, I've got to look at the numbers. What's the smallest tens value? Is it a 2?
Goes 2 for 6.
First, tell me how many numbers we have. I got to make sure we have the right amount of numbers. Somebody count those numbers.
Should be 20.
Do we have 20 numbers?
Yep.
20? Okay. All right. So y'all cross them out as we do it. So a 2 goes there. What's the smallest? Is it just 23? No?
Yeah.
23, 24.
27 and 29.
Okay, 23, 24, 27, 29.
33, 33, 36.
Wait, 33, 34. No, there's 2 33s.
Yeah, 2 33. Then a 36 and 38.
Okay, 2 33s, then a 36. I see the 36. I see the 38. Is that the only ones?
Give me here.
6, 8. All right, so far we have 8 numbers. We need 12 more numbers, right? Are there any 40s?
Yes.
40 a lot.
There's a 41. Anything smaller than a 41? Oh, there's 2 41s.
Yeah.
All right. 42?
Yep.
Yes. A 43? A 44? I don't see a 44. A 45? Is there just one?
There's
46? Just one? 47?
247.
2 47s? 48? I don't see a 48. 49? Is there just one of them? 5, 6, 7, 8, 9. So that's 17. We need 3 more. Any 50s? A 51? And a 54? Yes, is that it? And then there's 160, 67.